students, welcome to my classroom. Today we are going to study a very important topic from the chapter solutions, and that is the deviation from the Raoult's law. A lot of questions are asked in your CBSE exam from this topic, so let's start. First of all, before diving into the deviation, we should see what are the ideal solution. An ideal solution is a solution which is made from the two components. Suppose you have the 20 ml of the component A and you have 30 ml of the component B, and the resulting solution, which is prepared by mixing A and B, we expect should contain 50 ml overall. That means there is no change in the volume. Delta V mixing is equal to 0. At the same time, we also observe that there is no heat absorbed and no heat is released during the mixing of the components. If this is the situation, that is delta H mixing is equal to 0, and this solution, which is prepared by mixing A plus B, it follows Raoult's law. It follows Raoult's law at all concentrations. Then we say that this solution is an ideal solution. Now, why does this happen so? This happens so because the force of attraction between the components particles of the component A is equal to the force of attraction between the particles of component B, and which in turn is equal to force of attraction between the particles of A and B when they are mixed together to make the solution. So, while making the solution, if the interactions between the two components are same as they were between the particles of component B and as they were between the particles of component A. So, if these three kind of forces are equal, we say the solution is an ideal solution. For example, if you take a solution, say you have a mixture of N-hexane and this is mixed with the N-heptane, right? They make an ideal solution. How can we say they make an ideal solution? Because they fulfill all the conditions, that is delta V mixing is equal to 0, delta H mixing is 0, and number 3, this solution follows Raoult's law at all concentrations. ठीक है बच्चों, ऐसा होता है कि कुछ सॉल्यूशंस ऐसे भी होते हैं जो कि Raoult's लॉ को फॉलो नहीं करते. तो पहले हम देखते हैं कि ऐसे सॉल्यूशंस कौन कौन से होते हैं. फॉर एग्ज़ाम्पल, हम एक एग्ज़ाम्पल लेते हैं. जैसे हमने एग्ज़ाम्पल लिया, सपोज़ वी हैव a mixture of ethanol and a mixture of acetone, right? Now, in the mixture of ethanol and acetone, it has been observed that when these two components are mixed together, then delta H mixing is greater than 0. Also, it has been observed that delta V mixing is also equal to 0, and it has also been observed that the total partial pressure is more than what is expected by Raoult's law. It is more than what is expected by Raoult's law. Let us see why this happens. चलिए बच्चे हम देखें कि ऐसा क्यों होता है कि जो पार्शियल प्रेशर, जो टोटल प्रेशर होता है वो मोर देन व्हाट इज़ एक्सपेक्टेड बाय रॉल्ट्स लॉ क्यों होता है। ऐसा होता है बच्चों कि हमारा पहला कंपोनेंट जो ए है दैट इज़ इथाइल अल्कोहल C2H5OH। तो ये जो हमारा कंपोनेंट ए है इसमें इंट्रा मॉलिक्यूलर हाइड्रोजन बॉन्डिंग होती है। इंटरमॉलिक्यूलर हाइड्रोजन बॉन्डिंग क्या होगा इसमें कि ये O एंड H C2H5OH HO C2H5. So you can see कि there is intermolecular hydrogen bonding between the acetone molecule. There is intermolecular hydrogen bonding between the acetone molecule, and at the same time if you see the component B which is acetone CH3 C double bond O. Now this acetone is propanone chemically. If you see oxygen is very electronegative here, so it pulls the electron density towards itself. As a result it acquires partial negative charge, and carbon, because this electron density is drifted towards the oxygen, carbon acquires delta positive charge. So you can see कि this molecule shows polarity, and because of this there are dipole interactions between the acetone molecules. So this hydrogen bonding we can call it as FAA interaction, because this is between the component A's particle, and this dipole interaction we can denote by BFBB, right? This is this particular kind of interaction, hydrogen bonding between the component A. Then dipole interactions, they are existing between the component B. Now it has been seen that when these two components are mixed together, when A and B, when they are mixed, then the force of attraction which is there, that is the force of attraction between component A and ethyl alcohol, and force of interaction between A and B which is the acetone, of course it is there, but this interaction is quite weak. So what we found, that when the component A is mixed and component B is mixed, then forces of interaction between the particles of A and forces of interactions between the particles of B, they are more than the force of interaction between A and B. That means there is a weaker force between the component A and B. When this is the scenario, then what happens ki they can change into the vapors. They vaporize very easily because no one is pulling them back. There is hardly any force of attraction exerted on the particles of B by A, and hardly any force of attraction exerted by particles of B on A. So these force of interaction, they are weak. When this is the scenario, what will happen? They will vaporize and the pressure will be more. The total partial pressure will be more than expected, and we say the solution is showing the positive deviation from Raoult's law. आई होप ये आपको बच्चे समझ में आ रहा है. अगर आपको कोई भी कहीं आपके कोई डाउट आ रहा हो तो प्लीज़ फील फ्री टू राइट इन द कमेंट सेक्शन. तो अब यहाँ पर आप बच्चे ग्राफ में देखिए कि यहाँ ये जो ग्राफ था हमारा, एक जो आइडियल सॉल्यूशन होता है वो ये वाली स्ट्रेट लाइन दिखाता है. ठीक है, अब हमने ये जो आपको लाइन, एक कर्व्ड लाइन दिख रही है, दिस मीन्स द एक्स्ट्रा प्रेशर, कि जो राउल्ट्स लॉ प्रेडिक्ट करता है उससे एक्स्ट्रा प्रेशर है, क्योंकि ये जो 3 टाइप्स ऑफ इंटरेक्शंस हैं यहाँ पर, दे आर नॉट इक्वल एज द आइडियल सॉल्यूशंस शो. तो इसलिए जो टोटल प्रेशर होगा वो भी मोर देन द एक्सपेक्टेड है. सच काइंड ऑफ डेविएशन इज कॉल्ड द पॉजिटिव डेविएशन फ्रॉम द राउल्ट्स लॉ. So this is how it happens. Now let us take another example. Suppose I am taking the second case. In case 2, suppose our component A is chloroform and the component B is acetone, right? Now see, chloroform is CHCl3 and this acetone is propanone, that is CH3 C double bond O and CH3. Now when these two components they are mixed together, component A and B, हम उनकी बच्चे जब मिक्सिंग करते हैं तो क्या होता है, जो क्लोरोफॉर्म है, इफ़ आई राइट द स्ट्रक्चर लाइक दिस, Cl, there are 3 chlorines and here it is hydrogen. Now the chances of hydrogen bonding between acetone molecule and chloroform molecules are here. If you can see, hydrogen and oxygen, they are now bonded together by hydrogen bond. So this we can call, these kind of forces in the solution will exist and we call these forces as FAB, that is the force of interaction between the particle A and force of interaction between the particles of B, right? Now what we see, that here in this case the force of interaction between the chloroform, that is the component A, and the force of interaction between the component B, that is between the particles of B, FBB, these are weaker, but the force of interaction between A and B, that is because you can see the component A and B on mixing together, they have formed here hydrogen bonding. So if they want to vaporize, A is holding back B and B is holding back A from vaporizing. So in this case what happens, the expected total pressure is less than what is expected by Raoult's law. It is less than what is expected by Raoult's law. So in this solution what you will observe is that when these two components are mixed, then delta H mixing this will also be less than 0, and delta V mixing will also be less than 0, means because there is a force of attraction between them, so volume will be little less than what we are expecting. And we have seen that force of attraction between the component particles A and the force of attraction between the particles of component B, this will be less, and force of attraction between the particles of A and B will be more. So because the total partial pressure is less than what is expected by the Raoult's law, we say that this solution shows negative deviation from Raoult's law. Now look at the graph. In the negative deviation, because the total pressure is less than what we expect, so this was the line for the total pressure as per the ideal solutions as the Raoult's law predicts. But since now the pressure is less, so this curve is downward, right, because the total pressure is less. Now this contribution of the individual component, that will also be reduced, and similarly for the other component this will also be less than what is predicted by the Raoult's law. तो बच्चों थोड़ा सा ये एक नेक्स्ट वीडियो में मैं आपको एक ट्रिक बताने जाऊंगी. सपोज़ आपको जो है ऐसे MCQ क्वेश्चंस पूछे जाते हैं जिसमें आपको कुछ नंबर ऑफ कुछ कंपोनेंट्स दिए जाएंगे जैसे A और B, एंड जब उनको मिक्स किया जा रहा है, जब उनकी मिक्सिंग होती है तो वो किस तरह की डेविएशन शो करेंगे, वेदर दे विल शो पॉजिटिव डेविएशन और नेगेटिव डेविएशन, ये हम कैसे देखते हैं, एंड हाउ वी विल आंसर सच क्वेश्चंस that appear in the board exam, that we will do in the next video. So stay tuned till then, and very goodbye. Thanks for watching.